Section 3.6 has to do with perpendicular lines. The distance from a point to a line would be the line that is drawn from the point perpendicular to the line. So that's going to be the distance from the point to the line. You're not going to draw an angled line because that would not be the most direct route from the point to the line. The line, or the distance from a point to another line, is going to be the perpendicular line from the point to the line. So I take that point and I draw it perpendicular to the line. So that's going to be, it says draw the segment that represents the distance from the point P to AB. So this would have been P, and this would have been AB, and this would be the distance between point B and AB. The distance between two parallel lines would be the distance between one of the lines and any point on the other line, and it would be parallel. So if I go, I want to know from this point to this line, then I draw a perpendicular line. If I go, I want to know the distance from this point to this line, I draw a perpendicular line. In Theorem 3.9, it says in a plane, if two lines are equal distance from a third line, then the two lines are parallel to each other. So if this distance right here is the same as this distance right there, then I would know that A is parallel to C, because this third line is the same distance between those two. Problems concerning finding the distance between two lines can be put on a coordinate plane. This is where the crux of this particular section lies, and so it's asking you for what the distance between these two parallel lines are. So the first thing you're going to do is you're going to graph the line. So I have I'm going to go 1, 2, 3, okay, and then I'm going to go down 1 and over to the right, 1, 2, 3. Okay, so I have this blue line right here. This is y is equal to negative 1/3 x minus 3. And then I'm going to graph the other one. The other one I'm going to go up 1/3, and then I'm going to go down 1 and over to the right, 1, 2, 3. So approximately right there. These are going to be parallel lines. And this is y is equal to negative 1/3 x plus 1/3. Okay, the very first thing I'm going to do, so after I've drawn them on there, is I'm going to pick one y-intercept. And I'm going to pick this one so I don't have to deal with the fractions. So this point right here is the point 0, negative 3. Then what I'm trying to do is I'm trying to find the equation of the line that is perpendicular to that blue line where the y-intercept is and goes through the other line. So I want to find the equation of that red line. Okay, now you know if it's perpendicular, it has the opposite reciprocal slope. So I've got a slope of 3/1 or just 3. So the red line has a slope of 3, and it goes through the point 0, negative 3, because that's the y-intercept that it goes through. I know what that point is. So I can do the way of finding the equation of the line. So y is equal to 3x plus b. Okay, I plugged in the slope. Then I'm going to plug in the x and the y value. So negative 3 is equal to 3 times 0 plus b. And then I'm going to solve for the b. So that's going to give me that. So when I go back and write the equation, I get y is equal to 3x plus negative 3. That is going to be the equation for this red line. Y is equal to 3x plus negative 3. Now I'm going to put the green line equation and the red line equation into my calculator and find the point of intersection. So I'm going to go under y equals this one, the battery's dead. I need to get a different calculator here. So under y equals, you want to put the red equation, 3x plus negative 3. And then I want to put the green equation because I want to find that point. So negative 1 divided by 3x plus 1 divided by 3. And then I'm going to find the point that they intersect at. So I'm going to go second calculate. Find their point of intersection. And it's going to give me, this is the point 1, 0. Then if I have my distance formula in my calculator, I'm going to plug in this point and this point. I do not have it in that calculator, so I'm going to do it by hand. So remember, distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I've got 0 minus 1 squared plus negative 3 minus 0 squared. So that's going to give me 1 plus 9, because it's going to be negative 3 squared. So I'm going to have the distance here is going to be the square root of 10, which is approximately 3.16. If you have the distance formula in your calculator, you could plug that in right and just pop those vertices in there because you're looking for the distance from here to here. Alright, so I actually wrote the steps out for you. Okay, pick one of the y-intercepts, write the equation of the line that goes through the y-intercept and is perpendicular to the original line, the one having the y-intercept. Find the intersection between the perpendicular line and the other line and use the distance formula to find the distance between the intersection and the y-intercept you chose. Okay, we're going to do another one, working through the steps just like we did before. Okay, we're going to put these two on the graph. So I'm going to go up 3, and then I'm going to go up 2 and over to the right 1. So this should be the equation, y is equal to 2x plus 3. I think if you color code it, it will help you see it. We'll do the other one in green. So 1, 2, 3, there's my y-intercept. I'm going to go up 2 and to the right 1. This is y is equal to 2x minus 3. Alright, now I have to choose one of these y-intercepts. It does not matter which one you choose. I'm going to choose this one because that's going to be a positive value, so that's the 0.03. Then I'm going to draw a perpendicular line from that y-intercept perpendicular to the other line. I need to find, okay, if you look at the steps here, well, I've picked my y-intercept. That's going to be 0, 3. The next step is I write an equation of the line that goes through the y-intercept and is perpendicular to the original line. So it's perpendicular to both of these because they're parallel lines. So I need to find the equation of this red line. So I know it goes through the point 0, 3. But it is perpendicular to both of these, so I need the opposite reciprocal slope. So my slope is negative 1/2. So this is 2 over 1. I flip it, and take the opposite of it. Now I have to find the equation of the line, so I have y is equal to negative 1/2 x plus b. Plug in my x and my y. 3 is equal to negative 1/2 times 0 plus b. b is equal to 3. So the equation of the x, the red line, is y is equal to negative 1/2 x plus 3. Okay, so that's the equation of this line. Y is equal to negative 1/2 x plus 3. Now I need to use my calculator to find that point of intersection. So I'm going to put the red line in and the green line in. So 2x minus 3 and negative 1/2 x plus 3. I'm going to do second calculate and find the point of intersection. And it tells me that this point right here, where they intersect, is 2.4 and 1, hold on, let me rewrite that, 2.4 and 1.8. Okay, so that's going to be this point right here. So I want to find the distance between those. So again, if you have the distance formula in your calculator, you could use that. Or when you do it by hand, you have 0 minus 2.4 squared plus 3 minus 1.8 squared, x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared. So that's going to give me 2.4 squared, which is going to be 5.76, plus, and this is going to give me a 1.2 squared, which is going to be a 1.44. So I'm going to add those together, and it's going to give me the square root of 7.2, which is going to give me approximately 2.68. And so that is going to be the distance from this point to this point, which is the distance between those two lines. All right, now sometimes you have to rearrange them. I don't believe I can put this on the well, I might could. Let's rearrange it here. So I've got y is equal to negative 1/3 x plus 2, so that's going to be one equation. And then this one is going to be y is equal to negative 1/3 x plus, it's going to be negative 14 divided by 3, which is going to be a negative 4.6 with a line over it. Okay, so those are my two equations. I guess I can put them on, I could put them on here, I think. Okay, so I have a positive 2, and I go down 1 and over to the right 3. So y is equal to negative 1/3 x plus 2. And then I'm going to go down negative 4 and 4 and 2/3. 1, 2, 3, 4 and 2/3, which would be about right here, which is going to be my y-intercept on that one. And then I'm going to go down 1 and to the right 3. And what you draw should be parallel. So that's going to be y is equal to negative 1/3 x plus a negative 4.6. I would choose this y-intercept because it's not a fraction. So this is going to be the 0.02. So I want to know what the equation of the line is that goes through that y-intercept and is perpendicular to the line. So it's going to be perpendicular to both. So my equation, I'm using 0, 2, and then my slope is going to be the opposite reciprocal of these, so it's going to be 3. So I have y is equal to 3x plus b, and then I have 2 is equal to 3 times 0 plus b, or 2 equals b. So I have y is equal to 3x plus 2. That is the equation of this red line. So you're going to use, you want to find the intersection right here. So you're going to use the red line and the purple line. So I'm going to put in my calculator into y equals, I'm going to put 3x plus 2. Then I'm going to put negative 1 divided by 3, x. And then to make it more accurate, I'm going to put a negative 14 divided by 3, which is what that's approximately equal to. And then I'm going to find the point of intersection between those two. And it's going to give me a negative 2, negative 4. You can tell my line is just a little off here. All right, now I need to find the distance between 0, 2 and negative 2, negative 4. So I'm going to plug that into my distance formula. So I have negative 2 minus 0 squared plus negative 4 minus 2 squared. So that's going to give me a 4. This is going to give me a negative 6 squared, which is a 36. So I'm looking for the square root of 40. Which is equal to approximately 6.32. So that will be the distance between that green line and that purple line. All right, your homework on this is page 162 through 163, 12 through 16 even, and 20 through 24 even.